You know, I do a lot of videos about Terraform, and it's usually working with AWS or Microsoft Azure, but people have been asking me, Ned, where's the GCP love? And in this video, I'm going to show you how to get started with the Google Cloud Platform using Terraform. Hey, what's up, everybody? It's Ned Bellavance, Ned1313 on Twitter, and welcome to Terraform Tuesday. Today's topic is going to be all about using Terraform with the Google Cloud Platform, aka GCP. But before we talk about that, I've got two quick things for you. Number one, my Terraform Associate Certification Guide has been updated for Terraform 1.0. So if you've been thinking about getting your Terraform certification and taking the exam, check out my certification guide. The link is down in the description. The other thing that I want to mention is if you are interested in sponsoring my Terraform Tuesdays, hey, I am totally open to that. I've got opportunities where you could sponsor an entire episode, or you could just do some ads at the beginning or in the middle of the episode. So if that's of interest to you, please hit me up on Twitter. You know, my DMs are open, and let me know that you're interested, and we will get things started. With that out of the way, let's talk about using Terraform with GCP. Now, you know, I've used Terraform with a lot of different providers, obviously, and most commonly I'm using it with Microsoft Azure or AWS because that happens to be the clouds that I tend to work with and also the ones I've been requested to do stuff for. But there are a number of viewers that have requested for me to put something together for GCP. So that's what this video is about. Now, there's a few things you need to understand about GCP and a few things you need to understand about the provider. We'll start with the stuff around GCP in general. The first thing you need to know is the way that GCP is organized. What it has is a construct called projects. Any resource that you create inside GCP is going to be part of a project. And that project needs to have billing enabled in order for you to create resources. Now, what does that all mean? Let me try to boil this down. If you are most familiar with Microsoft Azure, then a billing account is kind of like a subscription. A subscription has some sort of payment tied to it, and a billing account has some type of payment tied to it. When you create resource groups in a subscription in Azure, they're associated with that subscription, and that's what gets billed. In Google, when you create a project, initially it's not associated with a subscription or billing account, so you have to associate it with a billing account. So that's one of the things we're going to have to do. Projects also allow you to do a bunch of other things. You can use them as a hierarchy to determine permissions and roles. So that is one way. Just like with a resource group, you can set permissions on a resource group and then resources inside that resource group. It's a very similar sort of setup. You can also create folders that have projects in them and create a hierarchy that way. And they all fold up into an organization. If you're familiar with Azure, that would kind of be like a management group. And then in your management group, you have subscriptions, and then your subscriptions, you have resource groups. So it's a similar sort of tree. In GCP, you've got organizations and then folders, and then you have projects inside those folders. So that's the whole sort of comparison between that and Microsoft Azure. Those are the two that I've had to do this with the most. So they're the ones that I really understand, but there's also parallels to draw to AWS. So that's out of the box, a couple things you need to understand about the way that Google set up. Now, let's talk about the provider a little bit. Out of all the providers, the Google one's kind of the weirdest because there's actually two providers. It's not just one. There's a regular Google provider for all of the services that are in GA. And then there's a second provider, the Google Beta provider, which is for all the services and resources that are in beta. Now, sometimes there's a version of a service that's in GA and then a different version of the service that's in beta. If you want to use both of those, you can create a provider for the regular and a provider for the beta. And then when you're instantiating that resource or that data source in the provider argument, you reference whether you want to use the regular Google or the Google beta provider. And obviously you can use aliases and all that kind of good stuff too. But just the main takeaway here is that there are two different providers. So if you're working with something that's in beta, you're going to need to instantiate the beta provider in addition to the regular provider. I found that very confusing at first, so I just want to get that out of the way right now. Other things the provider needs. Well, it needs a project to work with, and then it will use that project for any resources created within the configuration unless you override the project within the resource configuration. So it's going to inherit that project from the provider unless you explicitly change it to something else. So that's another thing to bear in mind. The last thing that I'll say about the provider is authentication. Obviously, you need to authenticate to be able to access resources through the GCP provider. And the way that you authenticate, well, there's 3 different ways. So let's talk about those. When it comes to using the Google provider, there are 3 different ways to approach authentication. And this actually applies to the Google beta provider as well as the regular, because the two have basically the same settings in them. The first way to do authentication is to use CLI-based authentication. Now, what does that mean? It means if you have the Google Cloud SDK installed, you can run gcloud init, and that configures credentials for your gcloud CLI. And then you can run a second command that will cache those credentials for Terraform to use. This is very similar. If you're using the Azure CLI, you can do AZ login to login, and then Terraform picks up on the fact that those credentials are cached. Same thing with the AWS CLI. If you run AWS configure, it will cache those credentials. So in the same way as those two, you can use gcloud init and then another command to cache the credentials for Terraform to use, and it'll just discover them. You don't have to do anything else in the provider configuration. So that's the first way. That's good for if you're running on a local workstation and you just want to try something out real quick. Not great if you're running in some sort of CI/CD context, or if you're running on a machine that's running in Google, which leads me to the second of 2 authentication methods. The second one is by using machine identity. So this would be a situation where you're running some sort of compute instance in the Google Cloud platform. When you're running one of those instances, you can give it a service account. And that service account can be assigned roles and permissions within GCP. What that means is when Terraform is running inside of that compute instance in GCP, it can discover that service account and use that for performing actions within GCP. So that's your second option, but that only really works if you're running in a compute instance inside GCP or something in GCP that has a service account. The third option here is to create a service account and then a service account key, which is a JSON file, and then specify that using either the credentials argument inside the provider or one of 3 different environment variables that are out there. And you can just set the path of the file or the actual file contents in that environment variable, and Terraform will find it and use it. Now, generally speaking, if you're running in a CI/CD kind of context, that's the option you're going to use. You're going to store it in an environment variable. Yes, you could store it as a file, but really you don't want sensitive data being stored as a file even on your runner machines. You'd rather keep it in an environment variable. You can do that. The easiest one to remember is Google_credentials. There are 2 others, but that's the one I tend to use because it's easy to remember, and I think it's also the shortest to type, and I'm lazy, so that's what I do. So those are the different authentication types that are available when it comes to GCP. The last thing that I want to mention is enabling APIs. And this is something that is fairly unique to GCP versus Azure or AWS. When you create a new project, it has no APIs enabled by default. APIs are what allow you to access the different services that are available inside of GCP. So if you want to use the compute engine, you have to enable the compute engine API. Now, because none of the APIs are enabled by default, when you're using Terraform, you have to either enable those APIs via Terraform or enable those APIs in the project before you try to use Terraform, because if you try to use Terraform and the API is not enabled, the Terraform apply or the Terraform plan will fail because it's going to go, hey, I'm trying to make these API calls and they're all getting rejected in the context of this project. So that's another thing to really keep in mind when it comes to using GCP and using the providers. You have to enable those APIs. Remember that, because otherwise that will come back to haunt you. Okay, I think I've covered everything I want to initially about the provider. So let's get into 2 examples. in our first example, we are simply going to spin up a compute engine instance inside of GCP. But before we do that, we have to take a few other steps to create a project, enable billing on that project, and then enable the API so that we can actually create the compute instance. So let's go over to Visual Studio Code now, and we will walk through that process. Okay, here we are in Visual Studio Code, and I have the directory Getting Started GCP open in the left. If you're looking for these files, you can always find them on my GitHub repository called Terraform Tuesdays. The link should appear or be on its way out right now. There we go. Okay, and we're first going to look through the README doc, and I put together a pretty good README doc for this one. Let's scroll down to the first example, and let's see, there we go, example 1. Okay, so we're gonna start out using a really simple example. If you want to follow along, you need to have a GCP account created, and you have to have a billing source enabled, a billing account enabled, and you need to have the Google Cloud SDK running locally, or you can launch the Cloud Shell from the console in GCP. Either one is fine. I'm going to be running this locally, so let's walk through that. We'll start by opening up the terminal, and we're going to run this first command here, gcloud init. Now, I've already run this, but I'm going to run it a second time just so you can see what's going to happen. And what it's going to do is it's going to tell me what I'm currently using for my configuration if I already have a configuration, which I do. And it's going to ask me if I want to update that. If I didn't already have a configuration, then it would pop open a browser window. I could select which Google account I want to use, and then it will ask me if I want to allow the Google Cloud SDK permissions to use my account. Now, I don't want to change anything here, so I'm just going to cancel out of this, but that gives you an idea of what's going on when you do gcloud init. Now, let's scroll down a little bit more, and the first thing that we want to do here is create a project that we're going to use in GCP. So I'm going to create a project ID, which will be taconet- a random ID that gets generated, and then I'll run the command gcloud projects create the project ID, and I'm going to do -- set as default. So that will become my default project for any future commands that I run. So let's go ahead and run those two commands first. Copy them and paste them down here. And it could take a moment for this project to create. It's usually pretty fast. The next command we're going to run is what caches my credentials and my project information locally so that Terraform can discover it. So gcloud auth application default login is what does this. So I'm going to go ahead and run that command now so that Terraform can find those credentials and use them. All right, so I'll go ahead and paste that down here, and it is going to pop up a URL because I'm using WSL. If you were running this in a native console, it would just pop open the browser window for you. I'm going to go ahead and click on that link, and it's going to open up in a separate browser, which I have open now in a separate monitor. So I'll go ahead and select the proper account that I want to use, and I'm going to allow the Google Auth library to use my Google account. I'll click on allow there. It's going to give me a code that I paste in. So I'll go ahead and paste that code in now. And now I am using that project, and it has my credentials cached so that Terraform can use it. So we're good on that end. All right, now that the project is created and we've got our credentials cached, now remember, the next thing we need to do is enable the API that we want to use, and we also have to associate billing with this project. So first, let me go over to the browser. There we go. And from within billing, I'm going to click on my projects, and now I should see the TacoNet project. There it is. We can see billing is currently disabled for that project. We need to enable that before we enable the Compute API and try to create something. So I'll go ahead and click on Change Billing here, and I will choose my billing account for Net in the Cloud and click on Set Account. Now billing has been enabled for that account. Let's go back to Visual Studio Code, and now we're going to enable the Compute Engine API by running gcloud services enable compute.googleapis.com. So I'll go ahead and grab that, copy and paste down below. There we go. Okay, that could take a moment for the API to be enabled. I found that usually the first API you enable takes a few minutes or a few seconds, and then additional APIs actually tend to take a lot less time. So let's go ahead and jump to when this API has finished enabling itself, and we'll get down into running our Terraform configuration. Okay, our API has successfully been enabled. So let's go ahead and hide the terminal. And the next thing we're going to do is take a look at the Terraform configuration we're using, and then we'll instantiate that Terraform configuration against the Google Cloud project that we've created. So the configuration we're looking at is an example one, and it's this main.tf file. So let's take a look at what's going on here. We have our standard Terraform block, and our required providers, I'm sourcing just the Google provider here. And I'm saying version 3.x. So this will keep me in the version 3 major version of the provider. And then I have a few variables, two variables defined here, the region where I'm going to create resources, and then the variable GCP project, which is the project where I'm going to create these resources. And then within my provider block, I defined the region and the project. Remember, the credentials is not necessary here because I have my credentials cached locally. Next, I'm going to query a data source of Google Compute Zones in the region that I'm currently using. And I don't have to tell it that because it will inherit that region from the provider. And from those available zones, I will use one of the zones to create my compute instance. Scrolling down a little bit more, I need a public IP address that I'm going to use for my instance. So I'm going to source that. It's Google Compute Address type. And then scrolling down some more, we have our Google Compute instance. I'm going to call it Apache because I'm going to install the Apache web server on it. For zone, I'm going to query the Google Compute Zones data source for the first entry in that list and use that as my zone. I'm going to add a network tag here called allow HTTP, which I'll use in tandem with a firewall rule in a moment to allow traffic on port 80. The machine type is E2-micro, which is the smallest E2 type, which I believe should be free. So hopefully it'll be free or basically no cost if you're following along. For the boot disk, I'm selecting the image Ubuntu OS Cloud, and I'm using the 1804 image that they have available. Scrolling down some more, we get into the network interface. The network I'm using is the default network that comes with that region. And I'm not going to get into GCP networking right now because it's a very complex topic, but just be aware, this is kind of like the default VPC, and we'll leave it at that. Under access config, I am saying that I want to NAT its private IP to a public IP address. And here's that address that I created with the previous resource, Google Compute address. And then lastly, I have a metadata startup script. So this is basically like user data or custom data. It's a script that's going to run when it starts up, and I'm passing it what's in the file startupscript.sh. This is a very basic script that just installs Apache, replaces the default web page, and that's pretty much it. Scrolling down a little bit more, here's that firewall rule that I was talking about. We're going to create a Google Compute firewall rule to allow HTTP. Under allow, we're going to say port 80 is allowed and the protocol is TCP. Target tags is if the traffic is on its way, the destination has a tag of allow HTTP, which we added to our compute instance, then allow that traffic. If it doesn't match that target tag, then don't allow it. And because we're not specifying a source, by default, the source is anywhere. Okay, and then lastly, priority 1000 just gives it higher priority than the default rules that are in the firewall. Lastly, for the output, we're going to have the public IP address. We're going to output that so that we can connect to the Apache server and just test to make sure that it's all running. Okay, so with that out of the way, I'll bring the terminal back up. We're already in example one, so I'm going to go through the standard Terraform process. And we'll start by doing Terraform init. And we're using the local backend here, so it's not going to have to initialize a remote backend or anything like that. There we go. It successfully downloaded the providers and it's initialized. You can run Terraform validate if you've made any changes and you just want to check. And then lastly, we're going to run Terraform plan. In the variables, we're going to pass it that project ID of the project that we just created, and we'll output that to a TF plan file. So we'll go ahead and run that command now. And that should take a moment to generate the plan that we want to run. Once it's done generating that plan, we'll go ahead and run Terraform apply. Looks like it's all good. So let's go ahead and grab that and copy it down here, and we'll run Terraform apply. And now it's going to go out and create those resources in the compute engine and the firewall and the address. So it's going through its process. This is not exciting. We've all seen this before. So I'm going to go ahead and jump to when the apply is complete, and then we can try using that public IP address to validate that the Apache server is running in our project. Okay, the apply process has completed. We've got our public IP address here. So I'm going to go ahead and copy that public IP address, and we'll go over to a browser. I'm going to go ahead and open up a new tab here. We'll go to http:// and there we go. No surprise, it's a bunch of tacos. So as we can see, it has created that compute instance, installed Apache, and put a custom web page in there. It's super simple, nothing too exciting here. Let's go ahead and close that, and we'll go back to Visual Studio Code and walk through the next example. Now, we just did a lot of work setting up a project before we could even use Terraform. And maybe you want to avoid all of that work. One of the ways that we can do that is by creating a Terraform service account that has permissions to create projects and enable APIs on that project. Wouldn't that be nice? Well, that is what example 2 is going to do. We're going to walk through the process of creating a service account for our service account in GCP. And then that service account will have permissions to create new projects in our organization. So you're going to need a GCP organization to do this, which is a little bit of a process to create an organization. It's a little bit more than just creating a project, but it's definitely worth it if you do want to follow along. And this is something you would do in a larger organization. In addition to creating that service account and the service account key, we're going to use Terraform Cloud as the back end to run this process, because I like to include Terraform Cloud, and I'll show you how you can get that service key in an environment variable that Terraform Cloud can use. So let's go back over to Visual Studio Code and start walking through the process. All right, now we're going to start walking through the process of creating a service account and what we're going to call an admin project that's going to have the capability of creating additional projects in the same organization. And we're going to enable those projects for billing, so we don't have to do that either. It's pretty slick. Now, this is all based off of a blog post on GCP, which I have linked in the README. So definitely take a look at that tutorial. If any of this seems confusing, I definitely borrowed heavily from that to show you this. That being said, first thing we're going to do is get our organization ID and our billing account ID, because we're going to use that information later on in our configuration. So let's go ahead and run these two commands here. Org ID equals gcloud organizations list. I'll output that in JSON, and I'll query the first name. And then, of course, they don't give you just the ID. It's organization/ID. So you have to take the ID out of that string. So that's what that whole command is doing. If you have multiple organizations, this is just grabbing the first. So you might have to tweak this command to grab the organization that you want to use. So I'll go ahead and copy that and bring the terminal back up, and I'll run that command. That runs pretty quick. And now I'm going to get my billing account. It's basically the same process, and I'm going to run that now, and we'll store it in billing account. Like the organization ID, I'm grabbing the first billing account. So if you have multiple billing accounts, you might have to tweak what number you're using in this JQ statement to grab the correct billing account. All right, so we have that information now. The next thing we're going to do is create an administrative project, which will house our service account, because service accounts need a project to live in. So we're going to create Terraform-admin-random number as a project ID. We'll go ahead and do that first. Copy. There we go. And paste. I'm good at this. I use keyboards. And then we're going to create a project with that project ID, and we're going to create it in the organization we want to use. So we have to specify that org ID, and we'll set it as default. So go ahead and grab those three now and run it down below. There we go. It is creating the project. And then the last thing we're going to do is link the billing account to that project ID. So now that project is enabled for that billing account. So I'll go ahead and grab that now. There we go. And go ahead and paste that down here. All right, so now that project is enabled for billing. Ooh, it did not like that. What didn't it like? Oh, cloud billing quota exceeded. I don't know what that is. All right, I had a little snafu there. It turned out I had maxed out my quota on billing accounts from doing all these demos, so I had to remove it from a few other projects so that I could assign the billing account to this project. So little bump in the road there, but hey, that's what happens when you're doing demos. So anyway, we've got the billing account linked to our main project, our admin project. Now we're going to create the service account that Terraform Cloud will use for its credentials when it wants to interact with GCP. So the first thing we're going to do is run gcloud im service account create Terraform and call it our Terraform Cloud account. So we'll go ahead and run that first. Do that down here. And that should go very quickly. All right, that's done. And now we are going to create the service account key, which will be stored in the project ID-key.json file in your home directory. And it's going to reference the IAM account that's in the current project that we're working in. So we'll go ahead and run that now and go ahead and paste that down here. There we go. Now we've created that file. That's good. We have a few policies that we want to bind to our service account. The first one is roles viewer. This lets it view all existing projects. The next one is resource manager project creator. This allows the service account to create new projects. And then the last one is billing.user. This allows the service account to assign billing to projects. Hey, look at what we did there. We gave it all the permissions it needs. So let's go ahead and grab these 3 permissions commands and go ahead and paste them down here. And once those have completed, now our service account has all the permissions it needs. Now we need to enable some APIs for our project so that it can interact with these other projects and also interact with billing and IAM. So I'm going to go ahead and run these 4 commands here to enable the necessary APIs. Go ahead and do that and hit enter. And now once those have completed, we'll be ready to start configuring Terraform Cloud. So while we're waiting for those APIs to enable, let's go over to Terraform Cloud and create a workspace for us to use. And we're going to call that workspace GCP Getting Started. So I'll go ahead and copy that and switch over to our browser. All right, here we are in the Terraform Cloud. I'm going to create a new workspace here. The type is CLI driven workflow because I'm going to be driving it from the CLI. And I'm going to go ahead and create that GCP Getting Started workspace. All right, that has been created. The next thing we're going to do is create some variables. So I'll click on variables and I'm going to create the first variable here. Let's go back to Visual Studio Code. The first variable I'm going to create is called billing account. So I'll go ahead and grab billing account here, copy it, and we'll go back to the browser. And I'll paste that in as the key. And then for the value, let's go back to Visual Studio Code. And I've got 2 echo commands here to echo the current billing account and org ID. So I'll paste those down here so I can get each of those. All right, so there's the billing account. I'm going to copy the billing account, go back and paste that in, and I will mark it as sensitive and save that variable. The second variable we're going to create is org ID. So I'll go ahead and copy that. We'll add that variable, paste it in, grab my org ID, go ahead and paste that in and set it as sensitive. Now, I don't know if either of these values do need to be sensitive, but it doesn't hurt to set them as sensitive. So that's what I've done. Those are the 2 variables we're going to need. And then lastly, for authentication purposes, we're going to set an environment variable. So I'll go ahead and add the variable here. We'll go back to Visual Studio Code. And that environment variable we're going to set is called Google Credentials. So I'll go ahead and copy that value and paste it in here. All right, so that's the key, is Google Credentials. Terraform will look for that environment variable and use what it finds in there. So now we need to specify the contents of our JSON file. Now, within Terraform Cloud, the environment variables cannot be multi-line, so we have to remove any line breaks from our JSON document. And we can do that by using JQ, and then we're going to get all of the contents of the JSON file, and we'll do -C to compact it and remove all of the line breaks. So I'll go ahead and run that now. Copy and paste. There we go. All right, here's the full value, and I probably need a little more room to work with it. So we'll move this up, and I'll go ahead and copy the entire contents. There we go. Copy. Back here, we'll paste it in the browser. We're going to mark it as sensitive because this is quite sensitive information. and we'll go ahead and save the variable. And there we go. Now we're all set. We've got our Terraform variables and our environment variables. Now you might be wondering what's in the Terraform configuration. Let's go check that out. All right, let me shrink back down the terminal. And I'll go ahead and hide it for now because we don't need it. And we'll take a look at our Terraform configuration that's in the example2 directory. So I'll go ahead and open up the 2 files that comprise it. And I'll close example1, not to confuse you. So in our terraform.tf, I just defined the required providers. That's the same. And the remote back end that's using my organization and the workspace that I created. Okay, we're good on that. Let's go over to main and see what we're doing here. We have our 2 variables that we specified, the billing account and the org ID. And then we also have a variable called region and one called prefix. The region is where we're going to create the projects, and the other one is the prefix naming for that project. We specify our provider is Google and specify the region, but not the project, because we don't need to specify that right now. And then we're going to get into a random ID for naming. And we're going to add the prefix variable to that random ID so we can use it to create a project. Next, we're going to create a Google project for the compute engine. And we're going to do that by creating a Google project with the name from the random ID with that prefix. Project ID is going to be the same. For the billing account, we'll give it the billing account value. And for the org ID, we'll give it the org ID value. It's pretty simple here. Nothing complex happening. And then because we want to make things easier for ourselves, we'll also pre-enable some APIs that we'll probably use for this project. And the way that we're going to do that is a for each loop inside this resource. So we're going to actually create 4 instances of this resource using a for each loop. And then we just have each API we want to enable. And that's going to be what goes into the service argument. We have each.key. So that's each key that's in our set, the project we want to enable it on, and whether or not to disable on destroy. That's set to false right now. So that's the configuration for the resource to enable all those APIs for our project. And then lastly, we will output the project ID, because that would be pretty useful as an output that somebody else could query as a data source when they're setting up their Terraform configuration leveraging GCP. Pretty cool, huh? Okay, let's go ahead and get this deployed. All right, so we are now going to deploy this second example using Terraform Cloud. If you aren't already logged into Terraform Cloud, you're going to have to run Terraform login from the command line and accept all of the things. I'm already logged into Terraform Cloud, so I don't need to do that. So I'll go ahead and open up the terminal again. Let's clear out what we've got going on here so we can actually see what we're doing. And I'll go ahead and run Terraform init here. Go ahead and paste that in. Initialize our configuration with the remote backend. There we go, that's done. And now I'm simply going to run Terraform apply-auto approve. So let me copy that and paste it down here. Now the way that Terraform Cloud works is it's going to run a plan first. And because I've done auto apply, then it will run, or auto approve, it's going to automatically apply that plan once the plan has been calculated. So it's spinning up a dedicated instance for us in Terraform Cloud to do this plan and apply, and then it will spin down that instance when it's done. Isn't that kind of nice? And it manages state for you. Not bad. All right, so it's done with its plan. It knows what it's going to do. Now it's going to go through the process of actually creating the project and enabling all of those APIs. Now, as usual, this isn't the most exciting thing to watch, so I'll go ahead and skip to the part where this has completed its apply. All right, our application has completed successfully. We can see it created a project called TacoNet 610 and then some other characters. So let's go over to the Cloud Console in GCP and verify that project is there. All right, here we are in the browser and I'm looking at Manage Resources, and we can see under the projects in my Net in the Cloud organization, there's the Terraform admin project where the Terraform service account lives. And then there's the TacoNet 610C5FD, which is the project it just created. And I also got that as an output, so now I could use that in a separate configuration to spin up resources. I've created a project creating engine. That's kind of nice, right? All right, in those 2 examples, we did 2 different things. We used the CLI authentication to authenticate to GCP and spin up a compute engine instance using Terraform. And then in the second example, we used a service account and Terraform Cloud to spin up a new project with APIs already enabled and billing enabled. So that's pretty useful if you're going to be spinning out a bunch of projects. Though, do mind that you have to increase the quota on your billing account if you're going to go over something like 10 associated projects, because otherwise you'll get that quota error that I got. So hopefully that helps you get started a little bit working with GCP and how you work with some of the resources in it. For the next video in the GCP series, I'm going to delve into deploying resources in GCP using GitHub Actions, because that was a request from a viewer. So thank you for that request, and that will be the next episode in the series. All right, that's going to do it for me for today. As always, thank you so much for watching. I really do appreciate it. Just a couple quick reminders. I want to plug my Patreon. If you've been enjoying these videos and you want to help support all of the time that I spend making these videos and demos, I'd really appreciate that. You can join the fine other patrons that are displayed right now and help me out a little bit. I really do appreciate it if you can spare a dime. If you can't, I also totally understand that too. For some people, times are tough. So if you can't and you just want to subscribe to the channel, that's awesome. Very much appreciated. If you want to give this video a like, I like that and I like you. We're friends. Yay. And then lastly, I just want to shout out a fellow YouTuber, a fellow YouTube channel. I did a great podcast recording with Michael Levan today, and I just wanted to highlight his YouTube channel. So I will definitely throw a link in the description, as well as a pop-up here somewhere to link to his YouTube channel. He's got a bunch of great content around using CDKs to deploy infrastructure as code. So definitely worth checking out. That'll do it for me for today. As always, thank you for watching. Until next time, stay healthy, stay safe out there. Bye for now. Let me tell you, I had some big plans to go to conferences and interview people and do awesome podcast episodes. I even went and bought this Zoom H6 recorder that can take up to 6 different inputs so I could go to these conferences, and I bought mics and I was all prepped. And then the pandemic happened. And I didn't get to go to conferences and record awesome podcasts. But you know what? Conferences are happening again, and I'm excited. I'm going to be out in the field with that recorder. If you happen to be at a conference and you want to record an episode with me, hey, I'll be there. Let's do it. All right. Bye now.